All right. Looking at our solving process, we are going to look at a couple of more situations that happen when we solve. And this is particular to when we combine like terms sometimes and what happens. All right. We've already talked about solving equations and sometimes having no solutions. We're going to run into another type of situation where that occurs. All right. Where we can possibly have no solution. So here to get you thinking about that, right, as an opener. And I would like you to solve A and B and see how you do solving both of those. So pause the video, solve both of those equations, and then think about, okay, so, all right, how are they the same, and then how are these problems different? All right, and I'll give you a minute or two to do that. So pause the video, solve those two problems, flip it back on, and we will discuss. All right, so I'm going to walk through this just to make sure you're good on all the steps, right? So how are they similar, right? Well, if I look at both problems, right, I have parentheses, all right, and they are open parentheses, so I should be able to distribute into both sets of parentheses, all right? So I'm going to do that. So 3 times 2x is 6x, 3 times 1 is 3, and I'm going to bring down the rest of the problem. So minus 6x plus 4 equals 9. Now I'm going to do the same thing over here because I can distribute the same way here. So 3 times 2x, that's 6x. 3 times 1 is 3. I'm going to bring down the rest of the problem here. So minus 6x plus 6 is equal to 9. All right, so first step, the same for both problems, right? Second step, I have like terms. All right, so I can combine those like terms, right? An x can go with another x, a number can go with another number. Now, but watch what happens, right? So when I combine like terms here, I have 6x minus 6x. Well, 6 minus 6 of anything, all right, is 0 of that something. So there's no more x's left. They're gone, right? So that's 0. So we don't have to write anything. But when I combine my like terms for my numbers, I have 3 plus 4, and I get 7 equals to 9. All right? Seems kind of weird. All right, well, let's look at what happens in part B here, right? Same idea. I'm going to combine like terms, all right? And I see something very similar here. I have 6x minus 6x. So once again, 6 of something minus 6 of that same something is 0 of that something, right? That is all gone. It's 0, all right? So there's no x's. Then I have 3 plus 6, which is 9 equals 9. All right, so now, how are these similar, right? Same process, right? We can distribute, we can combine like terms, right? Now, how are they different? Notice now, we have no more variables left in the problem. And notice I get 7 equals 9 here, which is a false statement. That doesn't make any sense, right? But I get 9 equals 9 here, which is a true statement. All right, now what does that mean? What is that telling me when I solve this? And that gets into the two ideas that we're going to talk about here, no solution and infinite solutions, right? Okay, so we've already talked about how to get no solutions because we don't get any points of intersection. All right, so now when we talk about no solutions here, all right, it's the same idea. All right, now when I look at this, all right, I get a false statement. So, all right, what are we looking for here? So if all the variables, all right, I'm going to put equal to 0, right? And we are left, all right, with a false statement, all right, then this is a no solution. All right, no solution problem there. Okay, so if all the variables equal to 0, so just like they did here, 6x minus 6x, that's 0, we don't write anything, gone. Okay, that's no solution, all right? Nothing is going to be true there. No matter what value of x we pick and plug it in here, we will always get a false statement. Now, infinitely many solutions. What this is really saying, right, is we have two of the same things, all right? And they're kind of laying on top of each other, so they're going to they would intersect at every point. This is why there's infinitely many solutions, all right? So it's really the same beginning here. So if all the variables, whatever variables we have in the problem, right, equal to 0, and we are left with a true statement, all right, then this is, and we're going to say IMS, right, infinitely many solutions, all right, IMS, all right. So No solution, infinitely many solutions. Now, once again, we won't know this until the very end. So you go through the problem, right, the exact same way. But you have to understand, okay, so what happens if all my variables equal to 0, right? I have to interpret that result. If it's a false statement, that means there are no solutions. If it's a true statement, that means there's infinitely many. So you can pick any value you want for x and plug it in here, all right, into this equation, and it will always work. All right, so for example, right, I'm just going to take, let's just take negative, or let's just take 4 and plug 4 in wherever there's an x. So I'd have 3, open parentheses, 2, and then for this x, I'm going to plug in 4. And then plus 1, close my parentheses, minus 6 times 4, all right, plus 6, and then what do I get? I get 9. So 9 equals 9. It's going to work. Well, let's pick another number. Let's pick 10 this time. So 3 times 2, and then I'm going to put in 10 instead of 4. All right. All right, and I must have hit something wrong there. Oh, I forgot my parentheses up here. So let me try that again. So 3 times 2 times 10, all right, plus 1, close my parentheses there. There we go. Let that off. Minus 6 times 10 plus 6. And I get 9 again. So no matter what x value you pick, it will always make this equation true. All right, and just the opposite. No matter what x value you pick here, it will always be false. So the good news is, right, there's nothing new as far as process. It's just interpreting when this happens, what that means. So let's go through a few examples here. So let's flip the page and let's look at problem 1. So once again, same steps, right? It doesn't change anything we do at the beginning. It just changes what we do at the end. So first problem here, all right? It's a linear problem, okay? All right, now I see parentheses. Are they open? Yes, so I can distribute into them. Now notice I have 2 sets of parentheses here. So I'm going to distribute in the first set. So 4 times 3x, that's 12x. 4 times negative 8 is negative 32. All right, now I am going to distribute for my second parentheses. It's also open. Now, you always take the sign with the number. So this is negative 6 times 2, and that's negative 12x. And then negative 6 times negative 4, all right, and that's positive 24, negative times negative, and that's equal to 8. So distribute, all right? Now I'm going to combine, all right? Now, once again, a number can go with a number, a variable to a variable. So I get 12x minus 12x. And we know that when we add things that are opposites, we get 0. So my variables are gone, okay? All right? Now I do negative 32 plus 24, and I get negative 8 is equal to 8. Okay, now I have to interpret, right? So I didn't change what I did, right? It's still distributed, still combined, but now I don't have any variables. So now I just ask myself, is this a true statement or a false statement? It is false, right? Now, if it's false, what does that mean? It means this is no solution, right? And so you actually need to make sure you write, right, the interpretation there. And then we're done. Okay, moving on to problem 2. I can see this is an absolute value problem. I'm expecting 2 solutions. Now I look, it's like, oh, I have parentheses. All right, are they open? Yes, there's no exponent. So now I can distribute. All right, so negative 3 times 3 is negative 9 absolute value of x. Negative 3 times 5, all right, that's negative 15. All right, and I can bring down the rest of the problem. Plus 9 equals 3. All right, notice I only have the one variable, so there's nothing to combine with. But I have 2 numbers here on the left side. So I can do this math fact, right? Negative 15 plus 9. So I bring down the negative 9 absolute value of x, and then minus 6 is equal to 3. Now, is it equal to 0? It is not. So now we make it equal to 0. So I'm going to do minus 3 minus 3. So negative 9 absolute value of x minus 9 is equal to 0. Now we can use our 0 property, right? What minus 9 is 0? I'm just going to move it up here to have a little bit of room, positive 9. So now, negative 9 absolute value of x, right, is equal to 9. Now it's a multiplication problem. Negative 9 times what is positive 9? Negative 9 times negative 1. All right, now this is what we've talked about before, right? When we get to the step, we know an absolute value cannot equal to a negative number. All right, so we know this is a no solution as well. Now it's a no solution for a different reason. All right, so all the things that we're learning are still appropriate, still true, right? But we also have another piece here that could lead to a different type of no solution. All right, let's move on to problem 3. Okay, when I look at problem 3, I see that I have x squared, so I know it's quadratic. That means I'm expecting 2 solutions. All right, I don't have any parentheses, so I don't have to worry about distributing. but I do see like terms. And we always want to combine like terms on one side if we can. So I'm going to do that. So negative 6x squared plus 6x squared. Negative 6 of something plus 6 of something, 0. They're gone. No more variables. Now, negative 16 plus 4 is negative 12. So I end up with negative 12 equals negative 12. All right, so once again, I have to interpret this, right? No variables. All right, I get a true statement this time. All right, so this means there are infinitely many solutions. All right, and hopefully you're seeing how all this fits together. So once again, if it's still a little confusing, all right, maybe make a note, all right, some questions, some clarifying things you want to talk about in class, and we go over this, all right, and we'll keep working through the problem to see how you do. Okay, let's look at problem 4 here, all right. So once again, I see that it's an exponential here and an exponential here, so I'm expecting one solution. All right, now I have parentheses. They're open, so I can distribute into those parentheses. So 4 times 2 to the x would be 4 2 to the x. All right, 4 times negative 8 is negative 32. And I'm going to bring down everything else here, right? So minus 32 plus 2 to the x equals 16. Now I have like terms, right? I have 4 2 to the x here plus 2 to the x here. So that would be 5 2 to the x's. All right, minus 32, minus 32. All right, like term, that would be minus 64 is equal to 16. Now, I have to get it equal to 0. So I'm going to subtract 16 from both sides. So 5 times 2 to the x is minus 80 is equal to 0. Now I can use my 0 property, right? What minus 80 is 0? And we know that's 80. All right, and so 5 times 2 to the x is equal to 80. Now it's a multiplication problem. 5 times 16 is 80. All right, so 2 to the x is equal to 16. And now I have to go through, all right, and just figure out what power of 2, right? So 2 to the 0 is 1, 2 to the first power is 2, 2 squared is 4, 2 to the third power is 8, 2 to the fourth power is 16. So my answer would be x equals, all right, 4. Okay, so this has to be 4 to get me to 16. So the same process that we're doing, right? And if we just get it, if our variable stays in the problem, we just solve like normal. All right, let's keep on keeping on. All right, so let's move down to number 5 here. All right, so I can see that this is a linear problem. All right, I have parentheses. I see that they're open, so I can distribute into them. So let's do so. So negative 7 times x is negative 7x. Negative 7 times 3 is negative 21. And we'll just bring down all the other stuff in our problem. Now we want to combine like terms. So I have a negative 7x plus 3x. So negative 7 plus 3 is negative 4x. And then I have negative 21 plus 1. So that's minus 20 is equal to 12. And then I just get it equal to 0. So I'm going to subtract 12 from both sides. Negative 4x minus 32 is equal to 0. All right. What minus 32 is 0? 32. So negative 4x equals 32. And then negative 4 times what is 32? And that answer would be negative 8. All right, so you can see that we're just working through the problem, right? As long as our variables stay in the problem, we just solve like normal. All right, let's try to do number 6 and get one more in here. All right, once again, I see that it's an absolute value problem. I'm going to expect 2 solutions. All right, now I have parentheses. They are open, so I can distribute into both of those. So let's take care of the first set there. So 6 times 3 absolute value of x would be 18 absolute value of x. 6 times 3 is 18. All right, 9 times 2 absolute value of x is 18 absolute value of x. And then 9 times 2 is 18. And then I'm going to bring down the equal to 18 here. Now I have like terms. I have a lot of 18s in this problem. All right, let's look at that. So I get 18 absolute value of x plus 18 absolute value of x. Now notice they're not opposites, right? So it's not going to be 0. So 18 plus 18 is 36 absolute value of x. And then 18 plus 18 here, all right, that would be plus 36. And then that would equal to 18. Now get it equal to 0, right? So I'm going to subtract 18, subtract 18. So 36 absolute value of x plus 18 is equal to 0. All right, so what plus 18 is equal to 0? And that would be negative 18. All right, so 36 times absolute value of x is equal to negative 18. Now, this isn't a math fact I know, right? 36 times something is equal to negative 18. So now I can undo that. So the opposite of multiplication is division. So I can take my calculator if I don't know that fact, right, and do like negative 18 divided by 36. And that's negative 0.5 or negative 1/2. So that means that absolute value of x would equal to negative 0.5. Now, once again, we get to this step, right? An absolute value cannot equal to a negative number. So we know this is no solution. All right, so there is our lesson on, right, interpreting the end of a problem. Get infinitely many solution or no solution. So once again, if you have questions, have those ready to go, and I will see you in class.